Kim Dundas and I'm a third-year PhD candidate supervised by Dr. Joseph Brooks at Keele University. So the cause of perceptual reversals that occur when we view ambiguous stimuli, like this Rubin spaces bars, has been attributed to several neural mechanisms. And one of these is that the neural representation of whichever version of the stimulus is currently dominating our perception becomes fatigued or adapted over time, until a point is reached where the alternate version of the stimulus is less fatigued, so our perception reverses. And behavioural studies have shown that presented an unambiguous adaptive stimulus can bias our perception of a subsequently presented ambiguous one. But we don't yet know if this adaptation mechanism has a role in the spontaneous reversals that occur when we view ambiguous stimuli with no preceding adaptive version. And so this is the question that we set out to answer using ambiguous motion and multivariate pattern analysis of EEG data. And whilst we collected EEG data, participants in our study were presented with pairs of motion stimuli that were arranged in 3 trial types. In adaptation trials, participants adapted to unambiguous motion before being presented with ambiguous motion. And our behavioural data shows that we did induce adaptation in these trials, as reversals occurred more often than chance. And in unbiased trials, unambiguous motion was again presented, but presented in such a way that it did not bias the perception of the ambiguous motion. And again, our behavioural data supports this, as reversal rate didn't differ from chance. And then finally, in ambiguous trials, only ambiguous motion was presented. So any reversals that occurred here occurred spontaneously, which is again supported by our behavioural data. And participants responded to these pairs by reporting the direction of motion that they saw. Trials were coded as reversals if different directions were reported, and as stable if the same direction was reported. And we then analysed the whole brain pattern of EEG data, only from when participants viewed the ambiguous motion in each trial type. And we did this by training 2 machine learning classifiers. One to recognise reversals from the adapted brain data, which I'll call the adaptive classifier, and one to recognise reversals from the unbiased brain data, which I'll call the unbiased classifier. And we then tested each of those classifiers on their ability to recognise reversals from the data collected during the ambiguous trials. So if the pattern of activity during the adapted reversals is more similar than the unbiased to that of spontaneously occurring reversals, then the adaptive classifier will be better at recognising spontaneous reversals than the unbiased classifier. And this is exactly what we found. The classifier that was trained on the adaptation-induced reversals was significantly better at recognising spontaneous reversals than the one that was trained on the unbiased. So this suggests that similar brain mechanisms mediate both adaptation and spontaneous perceptual reversals.